What's up, everyone? Welcome back. Patrick here, and moving on to the next question, we got to find f prime a of this function, the square root of 9 minus 5x, and we got to use both of these definitions here. So exact same process like I did in the previous video, but notice that here we're now going to be working with a square root function. So we got the limit as h approaches 0. We're going to use the first definition of f of a plus h minus f of a all over h. So what we got to do is, what's f of a plus h going to be? We're going to plug in this entire expression, a plus h, for the x value. So we'll have the square root of 9 minus 5 bracket a plus h minus f of a. We would just plug in a for the x value. So we'll have the square root of 9 minus 5a. This is going to be all over h. So let's simplify this a bit. Notice we can simplify here. Distribute that negative 5 inside the bracket. So we'll have the square root of 9 minus 5a minus 5h minus the square root of 9 minus 5a all over h. And notice at this point we can't plug in 0 for h yet because we still have this h in the denominator. So what we got to do here is we got to rationalize this. We got to multiply the numerator by its conjugate. So the conjugate would be 9 minus 5a minus 5h, and we would change this sign in the middle. All the signs under the square roots would stay the same, but this turns into a positive. Square root of 9 minus 5a all over square root of 9 minus 5a minus 5h plus square root of 9 minus 5a. So it's like we're taking this expression and multiplying it by 1. And I'm actually going to continue this up here because there's a lot going on. It's kind of wide. So we got the limit as h approaches 0. What's going to happen if we multiply this by its conjugate? Well, we just have to multiply those n values. So this times that would just be 9 minus 5a minus 5h. Negative times positive is negative, and then this times that. Both expressions are the same under the square root. So we just end up with that same expression, 9 minus 5a. And then these two expressions I'm going to keep separate. So we got h, this, times this entire expression. So the square root of 9 minus 5a minus 5h plus the square root of 9 minus 5a. Like that. Yeah, it's looking good so far. And then what we want to do is simplify that numerator. And notice how it simplifies pretty nicely. If we distribute that negative inside the bracket, we'll have negative 9 plus 5a. So notice 9 minus 9, and then negative 5a plus 5a. Those cancel out. And we're just left then with a negative 5h at the top. Denominator is going to stay the same. What am I forgetting here? No, not forgetting anything. We're all good. Sorry, I forgot that bracket there. Okay, and now notice these h's cancel out. And now we could plug in that h value of 0. So this here, this negative 5h would go to 0. So we'd be left with negative 5 over square root of 9 minus 5a plus square root of 9 minus 5a. And notice both of these are like terms because it's the same expression under the square root. So we would just add those two coefficients in front, and we'd be left with negative 5 over 2 square root of 9 minus 5a. So if you remember with square roots, if I got something like a root b plus c root b, those square roots are the same. This would equal the square root stays the same, and then we could just add those coefficients in front. It's exactly what I did here. There was like a 1 and a 1 in front there. So that became 2. So negative 5 all over 2 times square root of 9 minus 5a, that is f prime a for that function. And then let's use the second definition for this function, finding f prime a. Let's see if we get the same answer. So we'll have the limit as x approaches a of f of x, which is just the square root of 9 minus 5x, minus f of a, which is 9 minus 5a. This is going to be all over x minus a. So notice a lot less work with the second definition, a lot less expressions that we got to work with. So we got to notice we can't plug in a for x because we'd have that denominator be 0. So we got to do something to the numerator, see if we could cancel out this x minus a. So we would multiply by the conjugate, change that middle term, all over x minus, or all over the conjugate again. 9 minus 5x plus square root of 9 minus 5a. It's like we're multiplying this by 1. Then we'll have the limit as x approaches a. This times that is 9 minus 5x minus 9 minus square root of 9 minus 5a times the square root of 9 minus 5a. That's just 9 minus 5a. All over, let's keep these two separate. We got x minus a, square root of 9 minus 5x plus square root of 9 minus 5a. And then notice if we distribute that negative inside the bracket, the 9's cancel out, and then we'll end up having negative 5x plus 5a. Negative negative is a positive. So negative 5x plus 5a, or we could rewrite that. You know what? Let's actually keep it like that. So negative 5x plus 5a all over x minus a times the square root of 9 minus 5x plus the square root of 9 minus 5a. So notice now in the numerator we can factor out a negative 5. So if I do that, I'm not going to write in the next line. I'm just going to do it up here. If I factor out a negative 5, I'll just have x minus a left. And now notice those x minus a factors cancel out. And now we could plug in an a value for x. It's remaining here. So we'll have the square root of 9 minus 5a plus the square root of 9 minus 5a. Again, those are like terms like they were in the previous definition. And so we'll end up having that exact same thing, negative 5 all over 2 times square root of 9 minus 5a. So notice we got that exact same answer that we got with the first definition.